Hello everyone, I am your friend Shadab Imam, and today I have came up with an amazing problem which will help you not only to gain the concept but it will clear all your doubts regarding the transportation problem. So please watch the video till the end and subscribe the channel. So let us begin with the problem. The problem says that the following table shows a feasible solution to a transportation problem. So this is the given table. So this is the feasible solution for a given for a transportation problem. Is it optimal solution? So we have to find out if this particular solution is optimal, and if not, find an optimal solution using this feasible solution. Okay, so first of all we need to see what has given in our table. So in this particular table it has been said that this is a feasible solution, and once we look at the table we can identify that there are number of allocations. So if we count 1 2 3 4 5 6 7 8 9 10, so there are 10 number of allocations, and we know that for a basic feasible solution we have to have m plus n minus 1 number of allocations. So m is 4, n is 5, 4 plus 5 9 minus 1, that means 8. So for a basic feasible solution it must have 8 allocations, but right now this feasible solution has 10 number of allocation, that means it has 2 allocation more. So you must be thinking, how is it a feasible solution? So my friends, there is a difference between a feasible solution and a basic feasible solution, and we have studied the conditions that needed to be satisfied for a basic feasible solution. So first of all, let us check that how many conditions this matrix is going to satisfy to be a basic feasible solution. So the first condition is that all the demands and supply must be met. So let us see, this is 10 plus 30 40 plus 40 80 plus 20 100. So this is satisfying. Similarly 10 plus 20 plus 40 60, 30 plus 20 50, 30 plus 50 80. So all the supplies are satisfying. Similarly for the demand, we'll see 10 plus 20 is 30, 30 plus 30 is 60, 40 30 is 70, 40 50 is 90, and 20 20 is 40. So the first condition is satisfying, that means all the demand and supply are being satisfied. And the second condition is that the non-negativity restriction, that means all the allocations in each cell can be either 0 or positive. So we can see here that all the values are positive for the allocated cell, and for the non-allocated cell it will be 0. So our second condition also satisfies, but our third condition does not satisfy, as this feasible solution has 10 number of allocations, and for a basic feasible solution it must have 8 allocations. So we know that if the total number of allocation is increased by m plus n minus 1, then it will definitely form a loop. So as we see here, there are 2 more allocations. That means there should be 2 possible loop out there. So we need to find out those loops. So first of all, first loop can be easily identified as this. This is the first loop. Okay. So this is forming a loop. Okay. So now first we will consider this loop only. So what we will do to improve this feasible solution into a basic feasible solution is that either I am going to select any one of these 4 cells and I will allot one value at that particular C and see what is the effect in the overall transportation cost. So first of all, let us consider if I allocate plus 1, if allocate plus 1 in cell 1 5, okay, So 1 5 is this cell. So if I allocate this here, the overall transportation cost can be given as plus 6, this will be plus 6, minus 3, plus 3 and minus 3. So from this we can see that the overall change in the transportation cost is coming as plus 3. That means if I allocate 1 unit extra here, then the overall transportation cost is increased by 3. So what I'll do is I will withdraw 1 unit from here and do the same. So let us see what has happened. So if I withdraw 1 unit, this will be minus 6, this will be plus 3, this will be minus 3, this will be plus 3, and the plus 1 plus 3 total transportation cost will change into minus 3. That means if I withdraw 1 unit from here, then the overall transportation cost is decreased by 3. So what we will do is we will select a variable theta 1 and I will subtract theta 1 from here. And what is theta 1? Theta 1 is the maximum value that I can withdraw from here. So in order to maintain the supply and demand, if this is theta minus theta 1, this will be plus theta 1. If this is plus theta 1, this will be minus theta 1. And if this is minus theta 1, this will be plus theta 1. So our objective is to take out the maximum value as possible. So the cell where we have plus theta, this is 40 plus theta, this is 20 plus theta, we can allocate any quantity of theta 1 here, but our theta 1 is limited for 20 minus theta 1 and 30 minus theta 1. Here the maximum value of theta 1 can be 20, because if we increase more than that, this will be negative and it will violate the non-negativity restrictions. So here for this particular cell, theta 1 can be 20. Similarly for this particular cell, theta 1 can be 30. So 30 minus 30 will be 0. And among these two, we will select the minimum value of theta. That means here the theta 1 is coming as 20. So we will select the value of theta 1 as 20. And now let us see what is the change here. So I am writing in this new matrix here. So 20 minus 20 will be 0, that means no allocation will be here. Similarly 40 plus 20 is 60, so here this will become 60. Here 30 minus 20 is 10, so this will be 10, and this is 20 plus 20 is 40. So we can see that the number of allocation has been reduced from 4 to 3. Similarly, what we need to find out is there should be another loop, because there are 2 more allocations than m plus n minus 1. So there must be one more loop present in this matrix, and we need to find out that particular loop. So if you can see closely, you will find out that this is the given loop here. So this is the loop here, okay. And if I put plus 1 quantity in any of these allocated cells, then I need to find out the total change in the transportation cost. Suppose if I allocate the value plus 1 in cell 1 1, that means if I allocate plus 1 in this particular cell, then what is the change in transportation cost? This will be plus 2, this will be minus 3, this will be plus 7, this will be minus 4, this will be plus 5, this will be plus 4, this will be minus 2. So I have already taken 2 into account. So this will result in, this is 2 minus 3 plus 7 minus 4 plus 5 and minus 4. So this will be minus 4 and then plus 2. Okay, so from here we can see that this is minus 11, this is 12 plus 2, 14. So 11 minus 14, this will coming as plus 3. That means if I allocate 1 unit here, the overall change in the transportation cost is increased by 3. And if so, what I need to do here is I will withdraw 1 unit here, and the overall change in the transportation cost will be decreased by value 3. So if I allot 1 here, the transportation cost is increased by 3. If I withdraw from here, the transportation cost is decreased by 3. So I will take another variable which is theta 2. So theta 2, and I withdraw the value theta 2 here. So this will be minus theta 2, and theta 2 is the maximum quantity that I can withdraw from here. So in order to maintain the supply and demand, this will be minus theta 2, this will be plus theta 2, plus theta 2 minus theta 2, minus theta 2 plus theta 2, plus theta 2 minus theta 2, minus theta 2 plus theta 2. Now from here, the cell which have the value plus theta 2 can be increased indefinitely. So we need to ignore that. We will only see those cells which have the value minus theta 2. So here it is 10 minus theta 2, here it is this is theta 1, 10 minus theta 2, 30 minus theta 2 and 40 minus theta 2. So if we consider these 3 cells, the maximum value of theta 1 for this cell can be 10, maximum value of theta 2 for this cell can be 30, and maximum value for this cell can be 40. So theta 2 can be maximum 10 for this cell, maximum 30 for this cell, maximum 40 for this cell. So among these 3, we will select the minimum value of theta 2. So minimum value of theta 2 is coming here, where theta 2 is coming as 10. So we will select the value of theta 2 as equal to 10. Now let us now improve this solution. So I am writing the values in this new matrix. So this will be 10 minus 10 is 0, that means no allocation will be here. Similarly 30 plus theta 2, that means 30 plus 10 is 40, so this will become 40. Similarly we have 30 minus theta 2, that means 30 minus 10 is 20, so this will be 20. Similarly we have 50 plus theta 2, that means 50 plus 10 is 60, so this will be 60. Similarly we have 40 minus theta 2, that means 40 minus 10 is 30, this will be 30. Here it is 20 plus theta 2, that means 20 plus 10 is 30. So now we have improved our solution, and let us see how many number of allocations we have. 1 2 3 4 5 6 7 8. So now in this particular matrix we have m plus n minus 1 number of allocation. That means this particular solution is a basic feasible solution. So this is basic feasible solution. So from a feasible solution we have make our way to basic feasible solution, and now let us see that if this basic feasible solution is optimal or not. So we need to conduct an optimality test. So we will use modified distribution method, which is also known as MODI method. So in modified distribution method, what we will do is we will have a certain set of variables and we will calculate the values for these variables, taking any one of the variables value as 0. So for here we will select the value of u1 as 0. And now in order to find this, we need to remember that for allocated cell, Cij is equals to ui plus vj. That means for an allocated cell Cij, that means 3 unit transportation cost should be equal to ui plus vj. So for this particular cell, if Cij is 3, u1 is 0, that means v1 has to be equal to 3. So that 0 plus 3 equal to 3. Okay. So similarly we will calculate the remaining values. So let us calculate here. This is 0 plus what equal to 3. Again this will be 3. This will be okay. Once we have calculated this, this is 3 plus what equal to 7. So this will be 3 plus 4. 3 plus 4 equal to 7. Similarly 4 plus what? 4 plus what equal to 4. So we know that 4 plus 0 is 4. Similarly 0 plus what equal to 5. 0 plus 5 equal to 5. And this is 5 plus what equal to 4. This will be minus 1. Okay. This will be minus 1. And now okay, this is remaining 3 plus what equal to 3. So this will be 0, and 0 plus what equal to 3, that means this is 3. Now we need to calculate the values at non-basic cells, that means the cells we are empty. We need to calculate the value of Cij minus of ui plus vj. That is Cij is 2 minus 1 0 minus 1, that means minus 1. So 2 minus of minus 1 is plus 3. So this is the value we need to calculate at every non-basic cell. So this is 4 minus 0 is plus 4. 6 minus 3 is plus 3. 7 minus 8, 5 plus 3 is 8, so this will be minus 1. 6 plus 8 is minus 2. 7 plus 8 is minus 1. 7 plus 8 is minus 1, and 5 minus of minus 1 is plus 1, so this will be plus 6, and 6 minus 3 is plus 3. 4 minus 0 is plus 4, and 4, this is 4 minus 3 3, 4 minus 1 3, 4 minus 3 is plus 1, and this is 8 minus 7 is plus 1. Similarly here 8 minus 7 is plus 1. So now we have calculated the values at non-basic cell, and these values represent that if we allocate single quantity in this particular cell, the overall transportation cost will be increased or decreased. So we can see that from here, if we allocate in this particular cell, the overall transportation cost is decreased by 2. So what we will do is we will select this cell and we will try to allocate a value theta here, so that our transportation cost can be decreased. And by allocating here, again we are having more than m plus n minus 1 number of allocation. That means now this will definitely form a loop. So let us find out the loop here. So this will be, this is okay, this, so this is the loop. it is forming, we need to identify the loop, that is more important. Okay, so here it is forming a loop, and now we need to balance the supply and demand. So if this is plus 1, this plus theta, this will be minus theta, this will be plus theta, this will be minus theta, this will be plus theta, this will be minus theta. So again what we'll do is, we will see the cells which have value minus theta, because plus theta can be increased indefinitely. So we will see the cells which has the value minus theta. So this is 60 minus theta, this is 20 minus theta, this is 30 minus theta. So among these, for this particular cell, theta can be maximum 20, for this particular cell theta can be maximum 60, and for this particular cell theta can be maximum 30. So we need to select the minimum value of theta among these three. So we can see that the value here, that means theta equal to 20, is the minimum value of theta. So we will select the value of theta is equals to 20, and now we will see how our solution changes. So as we can see here, this will be 20 minus 20, that means there should be no allocation in this particular cell. This is 40 plus 20 is 60, so this will come as 60 here, this is 60, and this is 60 minus 20 is 40, so this will become 40, and this is plus theta, that means this will be plus 20 here, plus 20 here. This will be 30 minus 20 is 10, so this will become 10. This is 60 plus theta, that means 60 plus 20 is 80, so this is 80, and okay, 20 minus 20 is 0, and the unchanged allocations are 30. So this is 30, this is 10, this is 10, and this is 40, this is 40. Now we can see that still we have total 8 allocations, 1 2 3 4 5 6 7 8. So we still have m plus n minus 1 number of allocations, and now this is our improved solution. Now we need to see whether this solution is an optimal solution or not. So again we will do an optimality test, and for that we will have a set of variables u1, u2, u3, u4, v1, v2, v3, v4, v5, and we will take u1 equals to 0. So for allocated cell, we will see that Cij is equals to ui plus vj. From this equation we will calculate the values for all the variables, and for non-allocated cell we will calculate this value. So let us see 0 plus what equals to 3, so this will be 3. 0 plus what equal to 3, so this will again be 3, and this is 0 plus what equal to 6, 3 plus what equal to 6, so this will be 3. 3 plus 3 is 6. 3 plus what equals to 4, so this will be 1, and 3 plus what equal to 5, so this will be 2, and 2 plus what equal to 4, so this will also be 2. Then okay, 3 plus what equal to 3, so 3 plus 0 is 3. Now 0 plus what equal to 3, so 0 plus 3 is 3. So now we have calculated all the values of u's and v's. Now we need to calculate the values at non-basic cells, and we need to calculate this value, that is Cij, unit transportation cost, minus of ui plus vj. So let us quickly calculate this. So for this cell 2 minus 0 plus 1, that means 2 minus 1, so this will be plus 1. 4 minus 0 plus 2, that means 4 minus 2, plus 2. 6 minus 0 plus 3, that means plus 3. 7 minus of 6 is plus 1. 7 minus of 6 is plus 1. Here 5 minus of 1 is plus 4. 6 minus of 3 is plus 3. 4 minus of 2 is plus 2. And 4 minus of 3 is plus 1. 7 minus of 3 plus 2, 5. 7 minus 5 is plus 2. And 8 minus 5 is plus 3. Similarly, we have 8 minus 5, again we have plus 3. So here we can see that all the values in the non-basic cells are coming as positive. That means if we allocate in any of these cells, our overall transportation cost is going to increase only. So we are not able to improve our solution further. That means this obtained solution is the optimal solution, and we need to calculate the value of Z for this. So Z minimum is coming as 3 into 16, 180 plus 120 plus 120 plus 120 plus 50 plus 30 plus 120 plus 320. So if we calculate all these, we will get the value of Z as 1060, and this will be the minimum value of Z. That means Z can be minimum for this value, and for this, these are the optimal allocations. So if you like the lecture, please share the lecture. Have a nice day. Thank you.